Hey, there we go. Good evening, everybody, and welcome to this brand new like live stream concept that I'm trying out, and I hope you guys are gonna like it. I'm just gonna give you a quick rundown just to explain what this kind of is, as this is the first episode. So this live streaming series is called Curiosity Orbit. The idea with this is it's gonna be a monthly live stream. I'm gonna host once a month. I'm gonna get into some rhythm at some point. It's probably gonna be something like first Tuesday, first Wednesday, something like that. I'm gonna figure that out, but I'll let you know when I have a proper rhythm for it. But the idea with this live stream is that every month I host this. We talk about the latest news, both from astronomy, from astrophotography. We're gonna look at just the headline news. We're gonna look at new equipment releases, new software releases, anything that might affect you as an astronomy or astrophotographer interested person, if you will. And we're also going to be looking at, towards the end of the live stream, we're going to go through just the major events this month on the night sky. What is there to see that's out of the ordinary? Again, this is going to be a very broad, very high level. Just hopefully I'm going to be able to keep this relatively short. I don't want this to end up being like a multi-hour kind of thing. I want this to be short, compact, and then we can just go through and give you kind of the headline of the month. So that's the idea, and that's what I'm going to try to aim for. I just want to mention that if you head over to the channel's Discord server, I should probably put myself down there instead. Here, on the channel's Discord server, you will see there is now a channel here in the lobby area called Curiosity Orbit. And in here, you are very, very welcome. Hello, Alex. Welcome. In here, if you spot any news, if you see anything cool and you think, hey, this would be a really good topic for a news segment like this, I just dump a link in here, because then it just helps me a lot. I've already compiled a number of different sources that I'm looking at to try and compile all these news together. But if you spot something, do post them in here, because it makes my life a whole lot easier if people help me. If you spot something cool, then put that in there. So link for the channel's Discord server, of course, is in the description. So that's it. But I think we are going to just head out and start with the first. Let me just get a quick browser window. Hold on. Aha. Let's start with the first news that I want to cover this week. Sky and Telescope has a really interesting article that I want to talk about. And that is, of course, the Vera C. Cuban Observatory has released its first image, and it is glorious. I don't know if you guys have been following this observatory, but it is pretty amazing. It has, I think, the largest camera sensor built ever. It's something like 3,500 megapixels, so that would technically be 3.5 gigapixel. It's absolutely insane. And I think the main purpose of this telescope is going to be stuff like comet detection, meteorites, meteorites is later in his life, but meteoroids would be the correct term here. I need to do it right. But they're going to be looking for these kind of things, but they're also doing all kinds of other things. I believe also stuff like detecting supernova explosions in other galaxies. It's also stuff it's going to be looking at. And of course, especially if you're going to be looking at asteroids, you need that like extreme high resolution in order to see these small objects. Even though they're still going to be just 1 pixel. But as I said, Sky and Telescope has a really interesting article about it. But I want to go and actually look at the picture itself, because, as I said, they did release it. And as you can imagine, when you release a picture, here's basically the rundown of the telescope. So it has a 8.4 meter primary mirror, 3.5 meter secondary mirror, about a 3.5 degrees field of view, which is actually not like, it's not that narrow. It's actually pretty wide. Oh, sorry, I was wrong. It was 3.2 megapixels. So it's, yeah, 3.2 gigapixels, 3,200 megapixels. And it collects 20 terabytes of data every night. So, number of alerts per night. Yeah, okay, so it's cool. Let's go and see, where is that picture? I know I posted or saved a link for it where we could actually see, that picture. Let me just see if I can find that again. I think it is this link right here. Yes, so here we have that picture. This is the first one that's come from this telescope. Obviously, this, I think, is a stitch of 2. So the sensor itself is this kind of, it's not square. It's kind of this, they had a picture of it, I think, somewhere. It's not a square sensor, as you might imagine. Here, let's see. You can actually see if we open this image of a new tab there. That's the shape of the sensor. So the sensor is basically built up of multiple smaller sensors that's all just working together. And that's why that it's not a square sensor but has these like weird angles. That's also why we can see that here in the picture. But still, this is probably a mosaic of multiple. But here's the cool part. Take a look at this. If we take this and we say, oh, that's a cool galaxy. Let's zoom in on the galaxy here. And you can just zoom, and you can see that they had to implement something called LOD blending. It's called level of detail blending. Because this image is so big, they need to show a lower resolution of it when you zoom out, and then you get the high resolution data when you get in. This is absolutely insane. I mean, you see where we have just galaxies everywhere. Just a small galaxy there. Just follow that as we zoom out. It basically disappears. I don't know what the resolution of this image is, but it is quite impressive, I will have to say. I've been scrolling around this image for I don't know how long, and it's quite fun. I'll go ahead and I will post a link for you guys in the chat if you're interested. So you can go and play around with this yourself. I really recommend just like spend half an hour just clicking around it, looking at it, because you can see that galaxy that's tiny, but this in itself is a decent image of a galaxy. Also really interesting, like, diffraction patterns on the stars here. Clearly some kind of, you can see the spider veins from the secondary mirror here, right? But I'm wondering what causes all this color shift. I'm wondering if it has something to do with the weird sensor size that's caused these very, very different color diffractions around it. How does these ground-based observatories manage to negate all these satellites? So I think what they do, when they do something like this, I think what they do is basically just do sigma rejection on it. So they obviously take multiple pictures. As this main purpose of the telescope seems to be surveying and not necessarily imaging, that means it just takes pictures and looks for anything that moves, right? But what you probably do is if you take 2 pictures or 3 pictures, and let's say that there's a satellite that passes through one of them, that satellite would be in one picture, but not the 2 others. And that means you can just say, hey, if there's a pixel that is abnormally large, then the other pictures. Now, for 3 pictures, it doesn't make a ton of sense, but if you take, let's say, hundreds of pictures at the same time, and there's a satellite, then you would know one pixel would be multiple sigma away from the mean of all the others, and you would then just reject those pixels. So you don't have to reject the entire image, but you can reject just that line where the satellite passed through as you took it. I wish they had zoomed around mouse point. Oh, so that you could like just have your mouse pointer move around and then have like a like a magnifying glass kind of setup. Is that what you mean with the zoomed around mouse point? Or make it more intuitive? Yeah, maybe it would. I think what they wanted to do is that whole bar down here where you can see that right now we're oh, I see. Oh, I see what you're getting at. So yeah. Okay, so what you're saying is that when you zoom in, when you scroll, it doesn't scroll like if I put my mouse over that galaxy, it doesn't zoom in on the galaxy. It zooms in on wherever you are centered. Okay, yeah. I get what. Yeah, that would have been more. Yeah, so you have to constantly like, if I want to look at that galaxy, I have to zoom in and then go find the galaxy and then like zoom in again. Yeah, you're right. Absolutely, that would have been more intuitive. Absolutely, for sure. What's this red one down here? I just love these chains of galaxies. They just look amazing. I took an image of the what's it called, Macarian chain recently, and I just been a fan of these, kind of like the Hubble Deep Field image, if you know that one. I love those kind of like deep field images. Let's see if I can find my my Macarian chain image. Where is it? Why is it not in here? Here it is. That's my Macarian chain image. Not enough zoom power in this one as as the other one, but I think it's still pretty cool image. Anyway, that image out, like I said, link is in the chat if you guys want to go and have a look at it. And it will be interesting to see what else they're gonna do. But for sure, this is a great. You can see that the level LOD blending in effect here, where we have the low pixel and then slowly it loads in the high resolution image as you pan around. Go play around with it. It's quite fun, and yeah, I recommend that you spend a little bit of time just having some fun with that. Okay, let's move on to the next news, and the next news actually comes to us from James Webb. And again, I believe it is Sky and Telescope that has a article on it. Yes, it is. Awesome. Let's go and check it out. So the James Webb Space Telescope has discovered its first planet, which is pretty cool. We can actually see the image right here. If we open this up in a new tab. So what we're looking at here is kind of use the same tactic we do if you want to image the sun's corona. Is they have a blackout disk at the center where they're basically rejecting data from this area. And because they're rejecting data where the star is behind this black disk, that means that now they can, it doesn't get blown out as much, and that means they can now actually get images of what's happening around that star, because that planet there, as we can see right here, would absolutely be completely like overexposed, or overexposed, but overshadowed by the light from the star. But now we can actually see the planet itself. So the planet is around what's called a T-Tauri star, which is a very young star. So T-Tauri stars are non-fusioning stars that glow purely by their gravitational collapse. So these are stars that are not yet formed, but is in the forming process. And that means we also have a planet that's also probably very, very young. This one sits around 111 light years away, which is pretty close. It's not right in the backyard, but it's, around the corner kind of thing, compared to the Milky Way at least. I think we saw somewhere about the size of the planet itself. Where did they put that? Yeah, so the star is roughly 50 astronomical units from the star. More than 5 times further than Saturn is from the sun. So this is quite a large distance. So Saturn would still be the majority of our solar system will probably fit inside the black disk up here, I think. 15 astronomical units, that is quite far. It would usually mean the planet is cold and the system is young, so that makes sense. The planet still radiates heat from forming. So yeah, so the planet here is also glowing, if you will, because it is also still collapsing. Everything here is still collapsing. Everything's still being formed. But yeah, young. Yeah, okay. He actually put it in the title up here. It is only 6.4 million years old. That's nothing. That's yesterday in astronomical terms. So I think that's pretty cool. We got our first exoplanet out of James Webb, with probably a lot more to come. I'm gonna put the link for the Sky and Telescope article in the chat if you guys want to go and read it in more details for yourself. Cool. Okay, let's move over and let's talk software releases. So, last month, 13 days ago, today is the 2nd of July. So that would be on the 19th of June. ZWO released version 2.4 for the ASI Air. This was, of course, done to introduce their new electronic focuses that they have made. And we're just going to quickly go and talk about the new focuses, because we're going to come back to this software release, because there's some more to that than just the software release to update. ZWO has made a number of new autofocuses. I think this is called the Autofocuser Pro, and this one is distinctly different than the others. If you see the Pro one here, because as you can see, first of all, it now has a dedicated on-off switch on it itself. It also now has manual control, so you don't have to have it plugged in to anything actually in order to use it, because the thing also comes with a built-in battery. So you don't even have to plug in a USB-C or any kind of power. You can just charge it up and run it on its own. How long it's gonna run on a charge, I don't know, but I would expect at least a few nights. But yeah, the big thing here is, of course, USB interface now for power. Still a bell jack for a temperature probe or for a hand controller. But the main point here is it's now also, you can connect to it via Bluetooth, so you can connect to it wirelessly from your ASI Air. And this is, of course, part of ZWO's ongoing quest to make like astrophotography wireless, right? We've all tried it, where you have a ton of wires connecting, guide cameras connecting everything up to each other, and it's just like a crow's nest of wires. And that's what ZWO is trying to battle right now, where everything is going to communicate with each other wirelessly. That, of course, means everything's going to need its own batteries, as there's going to be no power cables. But this is a step in that direction. They've already taken huge steps in that direction by making these Air versions of their cameras that has both a guide sensor, a main sensor, and an ASI Air built into one unit. That, of course, removes a ton of cable clutter. This is the next step. Now, I'm not really sure. I haven't tried this, obviously, but I kind of like the idea of having the manual controls. I think is nice. So you have the option to just manually go and do some fine tuning if something is completely out of whack. I'm not so sure about the whole going wireless. I mean, it's nice not having the cables and all, but I don't know. Is it just me, or is like complete everything wireless also just asking for trouble? I mean, everywhere you read, they also say, yes, you should. I mean, technically you can connect to your mount as well wirelessly. The ASI Air supports that. Most of these astrocomputers support connecting wirelessly, but everyone says don't do it because it's not as reliable as running a physical cable. And I'm just thinking, God, I would hate sitting to troubleshoot wireless connections in the middle of the night when I just want to image. So anyway, But anyway, it is here. New autofocuser, on-off switch so you don't drain the battery, and manual controls. I actually don't know if now that it has a USB interface instead of the normal DC ports. No, did they run DC ports? Does the old one run DC ports? Or did the old one just run with the power from USB? Hold on, I need to check that. Let's just quickly... Electronic autofocusers. Is this the new one? The new USB-C one? Yeah, that's the new USB-C. So they're called N. They don't even have the original ones anymore on AstroStore. They only have the N version and the Pro. The Pro is the one we'll be looking at with the battery, right? Does the normal one, the normal N, does that have that doesn't have a battery, does it? Okay, I think I have an easier way we can figure that out. Hold on. We could just look at it instead of looking for pictures. I have it right here. So the old one, yeah, okay. So the old one is right here, and it just had a USB 2 port right there. And then, of course, you had your temperature probe next to it. Okay. Cable's not long enough. Okay, there we go. So, okay, so the new one just use USB-C, still gets power or USB, just as the old one, but they basically just replaced that USB-B, I think it is, with a USB-C port. Fair enough. The Pro version is, of course, the one with a battery. I am wondering, can we see the battery capacity of it? All metal housing. So even if we see the battery capacity, it doesn't tell us how long it can actually run. Here we go. Tested under standard condition in the ZW lab at room temperature. The device performed 2 focusing operations per hour, with each test session lasting 8 hours per night. Under these conditions, it was able to run stably for 7 consecutive nights. Okay, so room temperature, 2 focusing per hour, 6 hours run session. That's 16 focuses per night, if you will. And 7 consecutive nights. So that is 16 times 7. That is 102. Is that right? No, that's not right. Yes, it is right. 16 times 5. That doesn't make sense. No, yeah, because it's 7 times 10 is 70. 7 times 5 is 35. That's 105. Yeah, it's 105 plus 7. Yeah, okay, so it's 112. Sorry, that's my bad. Missed 10. 112 focusing routines that it was able to run. And also was probably standby for those 8 hours as well. But that was done at room temperature. Now, we all know how batteries perform in colder weather. And I would probably expect it to be somewhere like, if the battery was half doing actual operation, like half the capacity because of temperature, I wouldn't be surprised. So I would probably expect if you run 8-hour night sessions at colder temperatures, you should probably expect to see 3 to 4 nights of operation out of it. before the thing runs out of battery, which is fine, I think. Anyway, that was the new focuses from ZWO. But as I said, they did put these this out as part of the update 2.4 for the ASI Air. With it also comes a number of other updates. You could select your Bayer patterns for your DSLR cameras, some autofocus triggering in live view mode. There's a lot of other like small upgrades here and there. But most importantly, there's also a optimization to the all-sky polar alignment, which is an experimental function. However, this update had absolutely, I wouldn't say bricked, but there has been so many issues with the all-sky polar alignment, and I think also with some of the other features, to the point where people are beginning to roll back their updates for their ASI Airs because there is so many bugs around polar alignment with this update. It actually got so bad that ZWO, let's open this a new tab, that ZWO had to provide an apology. And they wanted to apologize for the release of the new 2.4. It caused some bugs and issues for a number of users. Yeah, they listed, so they were they were doing false meridian flips. That is currently being tested. This is again posted 8 days ago, so that was 5 days after the release. They come out with this apology. Yeah, so the exposure times for the... Okay, so apparently it has to do with the exposure times for polar alignment were too low, causing it to fail, which makes sense. Okay. And flats were also being... Oh yeah, and there was also problems with flat fields when you use the auto flat function, where it automatically determines the exposure times for your flat fields, so that it can auto do it when you swap filters. Then it can automatically like go and find the exposure time for that filter. That function was broken too, so it was overexposing the flats. And there was some other things. But anyway, there was a number of bugs with that, and I believe they are working on it. They have at least, the latest one that I saw was that they are currently working on a beta test for update, I can see this, it's up here in the header. They're currently working on a beta test for update 2.4.1. So it's still being tested right now. People are still giving them feedback. But anyway, if you have an ASI Air and you have not updated it yet, maybe wait a little. Unless you actually have to go image, then you might have to do it. But if you can at all, I would probably wait a little bit with updating your firmware to 2.4 or whatever, as it is at the time of this recording, still being actively worked on. I do have to give ZWO credit for one thing, though, and that is that they have acted very, very quickly to this. I mean, from when the release went out until they have identified, I mean, we could see in the previous article that they had identified all the issues. Fuck, you can't. I forgot to move over here. Shit, I've been talking about all these updates. Anyway, here you can see the article where they make the apology. And you can see here that they had, they issued the apologies 8 days ago. I would have to say that for ZWO that they have acted relatively quickly. And I think acting within 5 days is, in my mind, pretty good, actually. Okay, it's been 2 weeks now since the update was out, and the fix is still not out. It's a bit long, I would say. Now we would really like to see that update coming out soon, but at least they have the updates out for beta testing so that people can go and test it. I think that's good because obviously something went through the crack in their own internal testing. So it's nice to see that they're at least letting other people go out and test it before they release it, because they don't want to release a fix that then just didn't solve it or cause new issues. So, and yeah, there's a long forum thread here where people are giving feedback. They're discussing it back and forth, and we can see that the ZWO team is also responding, and people are talking and giving them feedback. If you want to dive into this, it just goes on and on and on, and you can see people posting their results, testing the new update. So there's a lot going on with this update. Check it out on the ZW homepage if you are interested in keeping yourself up with that. Now, of other software, not software releases, but hardware releases, there's something very interesting that's been released. I don't know if you guys have seen this. It's from a company. I believe it's a Greek company. Don't shoot me if I'm wrong. I believe it's a Greek company. They're called Pegasus Astro, and they have what they call the world's first smart eyepiece. If you don't know what a smart eyepiece is, I don't blame you, because until I saw this, I didn't really either. A smart eyepiece is essentially a mix between an astro camera and an eyepiece. It's essentially just an astro camera with an eyepiece at the back. However, the eyepiece is digital. That means you don't actually look at whatever you're looking at optically. It's just essentially a screen at the back of an astro camera. So the idea with this is that you have a sensor, an astro camera, that takes pictures, and it, as it does, let's store them on an SD card. Can we get a proper view of this? Do they have better pictures? Not great product shots they have here. Let's see if they have anything better. Okay, they don't. The idea is that this is, of course, their own marketing material. That this is what you would normally see if you just look through a normal eyepiece, but then it's able to do live stacking. So it takes pictures, and every 10 minutes, it takes that and it stacks into a new image. And what you see in the eyepiece is now going to be brighter and brighter over time. That's the idea, at least, that you get this. It is super cool. I do agree. It is a super cool concept. But at that point, I mean, why wouldn't you just take an astro camera and connect it to a screen and do live stacking, right? I mean, it's because you're not looking at anything optically anymore. It is just a screen at the back of a camera. I like the idea of it, but I'm not really sure if I'm 100% on board. I think it's a pretty cool concept, and it's very unique. I've never seen anything like this before. So I believe when they say they're world first, but also the whole, I think, like optical astronomy is kind of like, I don't know. I think a lot of the appeal for that is that it is optical, so that you are actually looking, there's no electronics here. It's just pure glass, mirrors, and physics that makes you see that image. But all of a sudden now we put a digital layer in between. So yeah, I can see maybe this is something I would put on a... if you have an observatory where you have a lot of guests, astro guests that comes out and needs to see something, I could see this actually being pretty cool. Because I've done tours on observatories before where we have non-astronomy people come in. And to be honest, because people are used to seeing these like hour-long stacks of images and they think that's what they're going to see in a telescope, but in most of the time it's not. But now it could actually be with an equipment thing. I think they have I'm not sure if this is a real or if this is a simulation. Music, could we mute the music maybe? Let me just check here. Good. Just want to make sure the music wasn't coming through. They have any images from solar system bodies? I don't know. You can see this is kind of that concept here, where it over time it gets clearer and clearer and clearer, and you get more and more details as the night goes on. Again, it just stacks a new image on top every 10 minutes. I don't think they have, it doesn't seem like they have any images of solar system bodies, but we can maybe check the sensor size. That's going to give us a good indication if they have any kind of hard specs on that. Here, so they have an IMX. Okay, so it's like a 533 sensor. Okay. We can just take. So it's essentially this. It's essentially like a. If you put this over to, because price-wise, it's going to be quite interesting as well. Let's change this over to euros. Here. So this is essentially the a ASI 336 MC Pro, because this is also cooled, but now you just have a screen on the back. And we can check here. Sensor size. Okay, it's a 1-inch sensor. So it's a square 1-inch diagonal sensor. It's a relatively large sensor. Because I think usually you would want smaller sensors when you're doing solar system stuff. What's the pixel size here? Yeah. So you can see here, your pixel size is just shy of 4 microns per pixel. I think if you want to have a good camera for planets, you want to get that number closer to 2, maybe less, if you're ideal. That being said, you can still do, whether have a high enough magnification scope, you can probably still put this and get some decent shots of a planet. But I think the pixel size is going to be a drawback if you want to do body solar system stuff. And I guess it kind of makes sense, because if you want to do solar system stuff with it, you don't really need that. The whole appeal of the sensor here, of this item here, is the fact that you can do stacking and see these fainter objects. You don't need the stacking when it comes to looking at solar systems as much. You can easily see those with a more traditional, pure, non-electronic or non-smart eyepiece. But with this, I think the whole appeal is deep sky objects. So from that perspective, I can kind of see why they went with this sensor. Getting a square sensor makes sense because you want to put it into a round field where you don't want to cut too much data off at the edges. So getting a square sensor makes a lot of sense. So I think that shows a good sensor for the product, but it would definitely be a more appeal, I think, towards deep sky objects rather than necessarily planetaries. But I don't have any images of it. I think who was it that did a was it Chive or was it Space Qualler that did a review of this? Let me just figure that out here. Hold on, give me a second. Yeah, it was Space Qualler. Here. Get you guys back here. Space Qualler, she did a review of it. I'm not gonna go and now there's ads. Not gonna go and show a whole lot from the video. If you want to go and see a full review of it, go check out the review on her channel. Maybe, I don't know, maybe she has some images of it. Okay, great. Let's move on to the next topic. And for the next topic, we are going to be jumping into Stellarium, because we're going to be talking about the night sky and what we're going to be able to see in the month to come, because there is actually a number of interesting targets. I'm just waiting for Stellarius to pop up. Here it is. There's a number of interesting opportunities that you can see here in the month of July. First of all, if we take and just remove this and this, if we take a quick look at Saturn, you will see that Saturn and Neptune is sitting awfully close to each other at the moment. So there's a great opportunity here. I believe they have their closest approach on the 6th. So there's a great opportunity here. Even with just handheld binoculars, you should be able to see both Saturn and Neptune at the same time. I believe close approach was it less than a degree? I mean, they're going to be pretty close. You might even if you have a wider field setup, actually be able to get an image or get both of them in a decent telescope as well. So there's a cool opportunity here. And if you want to make it even cooler, if we see here, if we just take Neptune here and we just open up the date and time control, and if we just fast forward to around the 12th, oh, where you go, Neptune? Stay with me. Let me just center that again. We move around to the 12th. Let's see here. Oh, wasn't it on the 12th? I believe it was on the 12th. Oh, I'm the wrong month. Hold on. Aha. There we go. Here we go. On the evening on the 12th, you have the moon coming in very close to both Saturn. So you have Neptune, you have Saturn down here, and then you have the moon up here. So again, getting those three basically on a line on the 12th of this month. Again, very cool opportunity to see. Again, you're going to need a relatively wide setup here if you want to be able to take any pictures of it. And you probably won't be able to see any details on Saturn because it's so small. At least compared, if you're going to go and get everything in frame, you're not going to be able to see details. But there is an opportunity here to get some rather unique shots. So I'll just take a quick look at all three of them at the same time, which I think is pretty cool. So that's an option coming up here on the 12th to see Saturn, Neptune, and the moon at the same time. Now, 12th of August. Oh, you're right. Hold on. Did I mess that up? Oh, well, that should have been next month then. Okay, we're gonna take I thought I messed that up then. I was sitting and looking at what was interesting to look at, and you're right. Where's the moon at? Wasn't there a close approach of the moon in this month as well? I think there was. There's the moon coming in. There we go. There's Saturn. Where did Neptune go? There's Neptune. So on the 16th, oh, damn it. Saturn, stay with me, Saturn. Here. There you go. There's your shot. You get the same opportunity on the 16th of this month. You can do it again, obviously, on the 12th next month, but here on the 16th, we have it. We have Saturn, Neptune, and then the moon sitting up here. Now, the problem is, as you can see here, this is from, this is daytime, which is not ideal. So it might not be possible to see as they are up during the day, but Saturn and Neptune is going to be up most of the night here in the Northern Hemisphere. If we move forward to, let's say, around midnight, we should still be able to see Saturn there if we re-enable the ground. It comes up here in the evening. So, and you still have the moon relatively close. Not as close as you would early in the night, but you still have Saturn coming up here in the late hours or early morning, and you still have Saturn, Neptune pretty close. So you can see those two, and maybe next month you're going to have a chance to also get it together with the moon at a bit later hour at that point. Okay, I want to move over to the Beehive cluster. Again, I'm not sure if that's going to be too visible. It's probably not. You can see how close it is to the sun, so it's going to be a very early morning target. If you want to see that, maybe at the beginning of the month, it's going to be better. I think it is, because what we're going to look at is on the 3rd. Here we go. That's a decent separation now. On the 3rd, you can see here we have Mercury moving very, very close. Oh, beehive, come on. You can see here Mercury going in very, very close. I think the closest approach is on the 3rd. There. Where you have Mercury and the beehive cluster sitting very close to each other. So once again, there is a photo opportunity right there. Separation to the sun is a bit narrower than I think most people would like. But it seems like in the early evenings, you can see we have the sun there. This is, of course, in Copenhagen. The beehive cluster already set. Oh, it is right there behind the fake tree here in Stellarium. But in the early evening, you might be able to catch the beehive cluster just before it sets, together with Mercury here around the 3rd, which is actually tomorrow. Again, there's a cool photo opportunity there as well if you want to have those two in frame at the same time. The beehive cluster is actually on my target list this year. I hope to get some images, because I want to try to do some clusters this year and have a long other list, but I'm gonna come back to that in a future video. But anyway, there's a photo up there where you can go and watch that. Other than that, we have a full moon on the 10th and we have a new moon on the 24th. So if you're gonna plan to do any deep sky objects, then towards the end of the month, it's definitely better in terms of pure darkness from the moon. Okay, those were the topics. As I said, I really want to try to keep these shows on a little bit shorter. And that also means they're going to be a little bit easier for people to consume when they come out as a VOD here afterwards. And again, I really need your guys' help with this. If you're not already on a Discord server, link should be in the description. And I would love if you guys spot anything cool, any cool topics or anything like that, come by the Discord server and post them in the Curiosity Orbit channel, because that just makes it easier for me to also go and find things, so I don't miss anything if any important things comes out that we need to talk about in these live streams. And of course, as this is a new concept, feedback. What do you guys think? Should I try? I was aiming for around an hour. We got in we're about 3/4 of an hour in. What do you guys think? Should I try to make them longer? Should we go into more details with each topic? Do we want them even shorter than this? I would really like your feedback on this concept, because I'm going to try to tailor it. I really want this to be a community thing. We can meet up every month and then talk about these things, or just watch the VOD on YouTube afterwards. So either give me feedback on YouTube, on Discord, or if you're watching the VOD afterwards, post a comment below what you think of the format, and I'm going to try to tailor it depending on what you guys want. So thanks a lot. I really hope you enjoyed it, and I'll talk to you guys on Discord or in the comment section.